the next thing on the agenda is what I've called the project briefing, to give an idea of where the project is. And I'll go first, and then Nick will have some things to add. So my end of the project has been so far the hardware. And can anybody see this camera view?
No.
How's that look? No good.
Your camera is blank right now. We're just getting.
Oh, my camera. Why don't I turn my camera on? How about turning the camera on?
That's
so
better.
That might work better.
This is the current hardware. And basically, it's a very small ESP32 module right here. This is called the ESP32C3-M1, which is a relatively new family member of the ESP32. It has a single RISC-V processor as its CPU, but it is otherwise highly compatible with the other ESP32 family members. Sitting next to it is a Dialog SLG 47007V-DIP, which is a long way of saying that it's a dual inline prototyping platform for this little itty bitty surface mount chip that's sitting in the middle of the board that might be visible as a little black square. And this is a mixed signal FPGA that contains both gates that can be connected up, as well as analog functional units, such as operational amplifiers. This one has a pair of programmable rheostats that can be combined into a programmable potentiometer with 2048 steps. It contains comparators and various other analog pieces. Over here is just a very simple USB powered 3.3 volt power supply and a USB interface chip to control the reset and the other control line into the ESP32, as well as passing serial data. And that's all there is to this. All of the pins of the FPGA board and the ESP32 module are all made available as both going down and coming up for solderless breadboard jumper wires. So there are a total of 38 pins, and the insertion force on this thing is right at the limit, I think, of the strength of the PCB. So it's kind of a insert once, now you're done inserting type of a situation, although it can be pried back out if you pry it up a little bit around the perimeter a little bit at a time. But the insertion force is extreme. And one of the things, one of the proposals is to only put the pins going down into either the ESP32 or the FPGA, but not both. That would make the insertion force much more manageable. The other thing is there's nothing at all underneath this part of the PC board. So this could hang right off the end of the solderless breadboard and it would reclaim a great deal of real estate over here on the other end of the solderless breadboard. So I think the next time you see this, this will be hanging off the end as an experiment. This is pretty close to the what we intend is the final design for this particular board. And by the way, we're shopping for a project name for it. There was some exchange on the Signal group, and I think the current leading candidate is some Marvel character called Mentacle or some such silly thing like that. But the remaining changes on the board to get this in what I would consider a completed state really just are cosmetic. There isn't any really basic functional change in expected, except there is a programmable LED here, and I want to add a jumper so that the control line controlling the LED can be freed up by pulling that jumper. This little module, C3 module, has relatively few I/O pins exposed compared to the more powerful dual core boards, but it is a pure subset, so it's highly compatible for the pins that it does have. The other thing is that we're running into a problem with this USB connector pulling off. Let me turn around so that you can actually see it. So this USB connector keeps breaking its solder joints even after being hand soldered, and so we're going to do something to make sure that that doesn't happen as often or becomes impossible. That's pretty much it. So there's just going to be some minor rearrangement, and we're going to declare victory on this particular design. Now, this entire board can be treated as a functional unit and put on a larger board as a module. And one idea is to make a next generation hardware device by simply having a 10 by 10 centimeter PC board, which is the sweet spot for very low cost overseas, and have this be a module on one end of the board, have some I/O expansion capabilities like PMOD, SPI, I2C, etc., but leave most of the rest of the board completely uncommitted for people's projects. That's pretty much as far as the hardware thinking has gone. So I've covered the current state and the immediate next steps. We've got parts to make another 12. We have components to make another 12 of these boards, not counting the PC boards themselves. And what I would like to do is get a PC board, make the next version, populate the next version, test the hell out of it, and then get 12 more boards, or 11, something, so that we can make a baker's dozen. And I think that that will give us some good availability for the short to medium term. Any questions about the hardware? Oh, I should mention also that this is version 0.7, and the 0.8 design is probably going to be promoted up to 1.0 as soon as it's proved out. I should also mention that this has expansion capabilities, so it's got it's got an I2C bus coming out, so you can daisy chain many more of these dip boards if you want to. You could stack them all over solderless breadboards and daisy chain them using that capability. Oh, and before I forget it, this same board supports a second mode, and instead of this dip format prototyping board, it supports the programming of surface mount chips by plugging into the middle two header female headers. This adapter can be put in, and the adapter holds the itty bitty SMT chip, which then gets captured in and can be programmed in place. It can also be run in simulation and for testing purposes before the program is actually committed to it. I think I've covered it now. Are there any questions? Okay.
One quick question is, so are
Sure.
there photos of that on Signal, Pete? The
Yes,
version that you
yes,
have
there are.
now?
Yeah, but the way Signal works is depending on when you joined. I'm pretty sure you were involved in it pretty early. But let me tell you what date those pictures are, and I can just basically copy. Oh, here they are. They just went by.
Well, I
But
think I do have those, but so is anything new since those 3 pictures are posted?
No, in fact, those 3. Let me just. Sorry, I while we were talking, I accidentally scrolled about 400 miles too far. Gonna get there any minute now, and remind myself.
Pete, are you trying to show something?
I'm scrolling through Signal, and please stand by.
It's not being shared to the meeting.
Yeah, that's a good idea because it's junk. I'm just scrolling through. Here we go. I'm almost to the pictures. Yeah, so as a note, there are pictures on Signal, but for the new members, they're not visible because of the semantics of the Signal measurement. I mean, not measurement, but membership thing.
It
So
doesn't show
what I
old
will,
posts to new people.
yeah, I will take an action item to cut and paste those things into the current Signal stream so that everybody can see. They're very high res, if I remember right. They're pretty high res pictures. So you can see.
Would that be a better place?
Okay.
Pete, would it be better to put them on GitHub?
If they're not on GitHub, they should be on GitHub already.
Okay.
I can tell you the path on. In fact, I can paste it.
It might be worth just linking the path and putting that in.
Yeah. Give me a second. Oh, that's the wrong. I'm in the wrong repository. So, without thinking, I named the hardware aardvark, as well as so that we've got kind of an overload in terms of the naming. And let's see.
Right, there's some ambiguity if you don't say aardvark software, aardvark hardware. If you say that, it's easy,
Yeah.
but if you don't, it's a little confusing.
Yeah, that's why I want to go with like Mentacle or some silly name like what was it, Dr. Octopus or some such.
Dr. Strange.
Here we go. I've got it now. I'm pasting it into the chat. And if you go to that page, you will see, actually, those are not photographs, are they? They are renderings of the PC board. Yeah, that's not very useful. Anyway, I'll take it as an action item to get this onto the into the repos, and we'll publish.
Why don't you put them in the README itself?
Yeah, they put it. Yeah,
put links to them in the README would be
I'll
great.
put it in the. I'll put it in. In fact, it might be in the README. I didn't look at the README file. But
well, you don't have the only thing in images is the circuits. So yeah, I would assume.
In fact, the images is a completely separate board that I'm just using as a reference design. It's a schematic, so it's not of any interest. Let me straighten this out, and
yeah, you can do that probably when we're not all online, and it'll be great.
Right.
Yep.
They'll give you time, and you don't have to do it as a performance art. I mean, you can if you want. Performance art is pretty cool, but I suspect it'll add to your overall complexity of your day.
All right, I will take care of that. So that leaves the other half of the project, which is firmware to enable the ESP32 to program the FPGA. And with that, over to Nick.
Oh, thank you. The software, there is a version of the software that Pete has copies of, which is entirely resident on the ESP32. There are problems doing that, but it makes the thing self-contained. The software, as it sits, requires that you configure it for whatever your wireless hub is, and then you can connect to it over the website. You can read, you can write, you can flash. Not being quite satisfied with that, I decided to go off on splitting for various reasons, some of which were actually good. I decided to split the software into two entirely separate groups. One is essentially the user interface. The second is the website that allows you to control it. That turned out to be a somewhat more interesting task. There are a number of items that prevent you from making calls across platforms. These are related to the security. It took a little bit of effort to work through that. I now have my internal version of the software, which allows you to do all of that. In the past, recently, I've had all sorts of interesting computer issues which have nothing to do with the substance going, but made me and deeply angered and annoyed me. But that's okay. We will recover. So there is this second piece of software which greatly reduces the amount of code that goes on the ESP. That allows for a couple things, one of which is that you can potentially do over-the-air flashing, one of which is that you can store multiple program modules which can be loaded at runtime. So you can have thing can serve various functions, and all of this can be. In the process of doing that, I wrote it basically as a JSON string language. So you give it a set of JSON strings which control the I2C and the flashing of the device. That's still fragile at this point, but it's basically functioning. So you have a language which through which you can communicate from any. You could write a Python script that would connect over the web to an IP address at which the ESP is found, and then completely control the ESP from that web interface. Doesn't have to be any sense local to it. That code is fragile but working. So that's basically the hardware status. I've sort of been working more on the newer version. However, in honor of this meeting, I got the old version, took it out, dusted it off, and made sure that Pete had a copy of it, because I get lost in my own software sometimes. So that's sort of the state of the hardware. I have pretty much complete control over the ESP and the dialog. The ability to make web calls across resources is I've pretty much mastered, but it's kind of tricky. You as I say, the ESP board could be in Poughkeepsie, it could be anywhere. You have a web interface that allows you to completely control the thing remotely at whatever IP it's addressed, and that I think is a kind of a neat thing to have done. Presumably, it all works.
Yeah. So you got to be careful with cross domain.
Very careful.
So the way I've always gotten around that in a professional environment is to have my own API do that call behind the scenes, so that the front end doesn't ever have to worry about it, because the security risk is when the front end is trying to do it, not when the back end is doing it.
It is the way that there is a protocol that allows for that to happen, called CORS. That requires that the back end be fully aware that somebody is going to start poking and prodding at it, and that there's an interchange which basically gives you authority to do that.
Right.
So
I know what CORS is. It's very common in the web world.
So I'm using the CORS interface, moving JSON strings. Is the approach. CORS is but so that's, you're familiar with how it goes together.
Right. So yeah, you originally wanted me to do some work for you in Python, but you never sent me this.
No. I'm still. I've had a particularly bad month with things, not going the way I happen to want them. I have not sent you that. My apologies.
No problem. I've been having a bad couple of weeks with my dog, so she's not doing well.
Yeah, well, I commiserate with you there. But yeah, I've got to, and that's one of the things that I wanted to discuss. There is between Pete and myself, there's now a shitload of specific knowledge about what to do, and probably a lot more about what not to do. And we are getting sort of ivory towered with that information. And the moving this meeting to a virtual meeting sort of led to what I think wants to happen is that we want to either using the ESP32 boards or using some straight ESP32s on a breadboard, we should on some Saturday run a 3, maybe 4 hour dump where we go through all the pieces. You're muted, Rob.
Rob, you're muted.
Sorry, I'm muted. Could we pick a Saturday afternoon would be great, or a weeknight, a Tuesday or a Wednesday weeknight, and we could take over a portion of the Forge and just have a couple of big tables for people to sit around and put things out in front and pull out laptops and just sort of have a jam session where anybody who wants to can get up to speed and have something moving maybe when we're done with it.
Yeah, I mean that's
the
idea. There's a whole bunch of specifics in terms of exactly how you use the ESP32 toolchain. I am not using the Arduino toolkit. I'm using the raw bare metal. That requires some very specific setups, and if you don't get it exactly right, then it don't work. And rather than going through a couple individuals and let's all share the pain. And if you can beat on me.
So I talked with Linda about it today, and we just need to find a time that works. And middle of the week evenings or Saturday afternoons. Saturday afternoons there'll be a little more competition for, but I think if we pick a Tuesday or Wednesday, or we pick a Saturday afternoon and are just a little thoughtful about it, we can make that work.
Okay, that's but it's do a whole debriefing session, because I can't keep all this information in my head. my head isn't that big.
100%, right.
Yeah, and there may be ways to simplify the command line tools. I think I know the tools you're using. So.
Yeah, no, I've done all of this sort of sitting in one room, kind of imagining it, and I'm probably wrong about some things.
Well, I just happened to be reading a couple of articles, either from Elector Magazine, Nuts and Bolts, or Circuit Seller, and we could bring that to the table too, because they talk about a couple of other different bare bones style tool chains, and also some different kinds of programmers to use.
Yeah, I mean that's rather than yeah, I mean it's time. I will share all of my pain, and it's it's whether I've got the architecture right. I've invented it. That's I'm in favor of one person kind of working out one way of doing it and then spreading it out and having everyone else beat on it.
Right, and then we'll all discover what works.
Let's discuss this. I am thinking that there needs to be basically text files that allow you to have commands, but I occasionally need to be beaten back into place.
So you usually.
I'll get with you and Pete, and we'll try and pick some possible dates, and then we'll come out for people to say, yeah, those dates work or not, so we can do that.
Okay.
I think that'd be great.
And I could use getting out and just because I need to say this is what I've done, because in some cases I did that, but I have no idea what I've done. That's the problem of doing coding by yourself. It occasionally needs to be a group activity.
Right, and normal for when you're out in the lead making things happen.
Yep,
absolutely normal.
It's called collaboration and peer review.
No, none of this peer review shit. That's crazy talk.
I'm talking about the casual. Oh, that's neat. Oh, how'd you do that? That kind of a thing. Not the formal. Okay, I'm grading your work.
Okay, let's take just a second to identify the meeting attendee number 10, who is named fellow Jitster. Could you identify yourself?
Could you turn your mic on?
Yeah.
You just have to move the mouse down to the middle bottom of the screen and then click on the microphone to unmute it. Okay.
Right, if you're hovering over the active window, then the menu shows up at the bottom. At the far right, it's got a hang up button. And if you're in the wrong meeting, you can use that, or you can unmute and talk to us.
It might be me. I don't know. Hey, guys, this is Kevin.
Yeah.
Hey,
Kevin.
Hey, guys.
Yeah. Why don't you type Kevin in the in your name area so we know who you are?
Well, we'll remember him. We know who he is now. Jamie, Kevin is an electrical engineer and FPGA expert in the area. Jamie Johnson is a absorber of new knowledge and a student who is looking to learn about FPGAs. So Kevin Schilf, Jamie Johnson.
Hey, Jamie.
Oh, there's nice to meet you. Hope to learn from you.
Well, we lost somebody.
Yeah, I think
maybe they'll come back.
I think he's re-logging in with his name. Nope, he's still. Oh no,
just re-logging in overall.
Okay, so let's look at the. We're not going to be able to do an Install-A-Thon tonight. The basic idea there was to get our hands on some of the pieces and parts, but primarily to see the drag and drop dialog synthesis tool in action for a few minutes and just
Actually,
get an
Rob's
idea.
idea of meeting in person over at the Forge Initiative or something, that would make a great Install-A-Thon time.
Yeah,
Yeah, I was thinking that.
I think you're totally right. We may not do it all in the same day, but for sure, getting everybody bootstrapped with the tool chains and tools that they would like to get involved with would also be part of that. And trying out, actually hands-on trying out the hardware is also not going to be on the list tonight, but that's okay.
Do you think you might be able to show us, share a screen with the drag and drop or anything like that? That would be cool if anybody has it up.
It's it's on a different. No, is a simple answer.
Oh, okay, that's
you
cool.
know, it's I can hum and haw the fuck no. No,
it doesn't work.
Okay.
That's all. It doesn't work in terms of Jitsi. That's fine.
It works.
No, the software works. I mean, Jitsi and it don't work together at the moment.
Yeah, I mean it's you know, it works. I'm unhappy with it. I would prefer to sit down.
Why would you be happy with it? Sorry, go ahead.
I would prefer to sit down and be beaten up in person.
I'm trying to see if I could bring it up so that we can see what it looks like. Where did I put it? Here it is.
See,
Let me see if I can get it started and do a share screen.
In the process, my environment got badly munched, and so I had to do a complete reinstall of Linux on the system, and I don't have cameras and stuff on that system. Let's see, could I? No, I don't have the, I don't have everything set up on that system, so no. No excuses. I'm wrong. My bad, but no.
No, it's all good. It was just if it were going to work out, that would have been really cool.
I know it would have been. I'm not. It's
Let's see if I can make this do something.
Let's see. Well, it may be.
I've got it. Hey, Nick.
Yep.
I've got it started up. So let me do a share screen.
Okay.
And just a second. Turn on my camera. Share screen.
Okay, let's see how it's.
Choose what to share.
We see your entire.
We have to stand by just a second, okay?
Yeah, you pick
so I
your
have to
whole
put in
desktop.
some.
You'll want to pick a window.
Would you just stand by, okay? Just hold your water for a minute. So Nick, I need to put in believable VDD values. Is that all I need? The typical values like 3.3.
Yes, I mean for that, yeah, you've got to put in. It doesn't really matter. It only uses that in the simulation.
Right.
But you've got to have values in there.
So what do you guys see now?
Your whole screen of all your windows. There you go.
Is the dialog synthesis tool the whole screen now?
Yeah.
No, we see just what you want us to see.
Yep. Now, what you're seeing there is the 20 or so I/O pins from the dialog chip itself. 2 of them are obviously power. 2 of them are the I2C interface. What you see is, if you can zoom in a little, Pete.
I'm looking for the zoom, and I have this fantastic.
Down in the lower left. Should be way down the bottom left. I think you'll find it.
Yep. Yeah, I'm looking. How's
okay.
that?
What you see in the diagram is the auto zeroing op amp. I believe you see the two resistor
Rheostats?
ladders, and the thing in the center lower portion is probably the I2C. I can't see that. You've got over on the right hand side of the screen, you have a number of objects that you can turn on. So there are two uncommitted op amps, there's a voltage reference, there's a bunch of digital blocks, and you can, by going to the right hand side block of the right hand side, you can select which of those blocks. You've just dropped a couple of the op amps. You can then drop and drag and connect the op amps to there are restrictions, but you can connect those op amps to various pins. So if the auto zeroing op amps, let's say there are peculiar restrictions which are in the routing, but you've got a voltage reference. You can, for example, take the Pete's doing it now. You can take and connect the one of the resistor networks to the programmable gain amplifier and essentially select gain. You can bring the voltage reference. There are some comparators in there which you can use for high and low triggers. There are some voltage references which you can set. You can use a voltage reference and a comparator to set a particular voltage level, and which you could turn into an oscillator. There are oscillators on the thing, so you can do a divide by a billion. Depending upon the device, there's crystal oscillators. There's a
Temperature sensor?
About 20 devices. Some of them have high voltage outputs, high voltage in their world being 12 volts. Some of them have stepper motor drivers, or all the makings of a stepper motor driver. What you have to connect it up and then connect the pins to it. There are some, I think there are some IGBT drivers. So you've got basically, watchdog counters. You've got a whole bunch of building blocks that you can select and modify. There are 2,048 cells in the file. Each cell is essentially a crossing point where something is connected to something, and the connection is done in sort of this firmware thing. So with all the devices, you design whatever you're going to do in this drop and drag interface. You can simulate it. It has its own output is a GP6 file. In the later versions of the code, I can actually dynamically read the GP6 file. In the early versions of the code, this program dumps basically a binary dump of all of the connections, which you then have to read and interpret, and then you move that out via I2C to the Dialog chips. You can move it out to the RAM, in which case it's temporary, or you can move it to the EEPROM, in which case when the system boots up, it automatically loads it to the RAM. We didn't create this particular thing. What we did, this is, I would like to take credit for it, but that would be dishonest, and I'm never dishonest. What we created was the web interface and the fixings around the ESP32, so that you've got basically a complete system. The boards are, we kind of wanted to make something that you could, in a classroom, you could have a whole classroom full of people, and for $10 they could get little computer boards which they could program and made out of existing components. We started out with the intention of using a much larger, more standard FPGA, which is, you know, still low cost, but this looked to be extremely attractive because it has a whole bunch of analog functions. And there's that the classic thing you do with a straight FPGA is you do a counter. Okay, we can count to 1,000,000. Big deal. This, at least you can do op amps, and you can have it as a one-time erstwhile analog engineer. This introduces people to the fact that the world is not entirely digital. So the point was, it's a very low cost. These chips are, you know, in the dollar range. It's a very low cost way of introducing people to both analog and FPGA. Now, there are enough functions on the ESP32C2. There are A to D converters which have to be buffered, and combining this chip with that chip allows you to basically generate a complete system. As I say, my target is something that will read muscle inputs, neuromuscular inputs, and that is eminently possible with the stuff that we have on this chip. You've got very low offsets, voltage offsets. You've got everything there which would be necessary to do that. And that I think is a hell of a lot better than the standard blinky lights. You know, we can count to 1,000,000 FPGA stuff. My apologies. I should watch my language a little more. But I'm colorful. If Johnny Depp can be colorful, I can be colorful. So that's sort
okay.
of that's sort of generally. This is the Dialog tool. It's not something that I can take credit for.
Right. So this to put it in a different perspective, this takes the place of the more typical Verilog or VHDL language interface for specifying the gate array. And so it's a very, very simple drag and drop. I've got a design rule violated, so I can't get the debugger to run. The debugger dialog over here to come up, but we'll all be seeing more of this in the future. I'm curious whether the resolution of the screen allows you to see what these components are. Does anybody see?
Yes. Well, no, it's difficult for us to see. You can in real life see it.
Well,
right. We can sort of see a shape on your screen. That's about it.
Basically,
we can't read the values, but we can pretty much tell what the parts are.
Okay, so this is a big deal feature in my opinion. For a set of common components, you can define external components, and the simulation can include those. So here's an inductor, here's a Schottky diode,
that's cool.
capacitor, and you can just drag and drop these parts until you get tired. Here's a brushed DC motor. Whoops. Yeah, here's a brushed DC motor. I think there are some, there's some stepper motors, NPN transistors, PNP, NMOS, PMOS, field effect transistors, voltage sources, current sources, and that's about it. So, and resistors.
And
don't forget the resistors.
Some of the Dialog parts, you actually have the H-bridge drivers to be able to drive a servo motor. So it's just a matter of, you know, plunking in. I believe they're 2 amps, so you can drive 2 amps, 12 volts, which is not bad. and you can make the motor go whir one direction and whir the other direction, and you've got you can. There's a what they have a book full of suggested projects. There are a couple hundred of them. There are metal detectors. If you want to wind a coil, you've got enough components on one of the boards to be able to do a complete high-grade metal detector. So you've got all sorts of you've got literally hundreds of app notes outlining what you can do with that.
Also, some of the parts operate at automotive temperature ranges. So a limited a subset of the parts can tolerate extreme temperature situations.
Pete, can I ask you a quick question about the GUI that you're showing us right in front of us now?
Yes.
Is that Aardvark or is that the Dialog programming interface? I couldn't tell what you were saying.
This is the Dialog product. This is the Dialog FPGA
right. This
synthesis
is from the
tool.
vendor who sells the FPGAs, and then Aardvark allows us to take the output of this and load it on to the FPGA board. Right. That's what I thought.
Exactly.
Okay.
Right. Right.
So if you take this tool, you create a binary or an image, and then you can use the Aardvark to get that image onto the Dialog chip that lives on the Aardvark hardware, or
Correct.
the DocOC hardware, or whatever the right words are these days. Cool.
Yeah.
So
that's what I thought was going on.
So if you wanted to run your robots, you've got essentially an I2C interface where you can dump data to you could dump speed, you can run servo motors, and all of these are done in tiny 20-pin DIP chips, tiny little 20-pin devices. So you can run stepper motors, and you can distribute the intelligence.
I'm looking forward to monitoring some systems using these. I think it's going to go really well.
Many of the parts are only available in ridiculously small surface mount packages, but they have made these little DIP evaluation boards so affordable that it requires kind of a specialized circumstance for us to be motivated to design in and deal with the assembly of the surface mount parts. We can get a lot of mileage out of the DIP boards, and then over time we can make assembled daughter boards containing the surface mount parts with whatever customization is appropriate. But for right now, Dialog has provided all of the essentials except for a reasonable programming interface, which is what Nick's created.
And what you thinking a couple steps ahead, the ESP32C3s are half the size of a postage stamp. You could create a board not much bigger than a postage stamp that has Wi-Fi, Bluetooth, A to D converters, a bunch of op amps, battery charging circuits, a whole bunch of stuff in this minuscule package. And that I think there's some fun to be had there.
Yeah, I think it might be so small that the only way I would get it assembled would be to, having designed it, send it to somebody who assembles stuff at this scale.
Well, there are a bunch of little people you can hire to do that.
Oh, good, because I have trouble soldering things that small. Yeah. But if I can hire those really, really millimeter height people, they're going to find it easy.
Don't feel lonely, Rob. I despise tiny QFN packages. They're very difficult to hand place, and when something goes wrong, it's very hard to know what what mistake you made.
Right.
So
But we'll get to where we can build those packages.
And these things are these are unusually small packages, also, like 2 by 3 millimeter type insanity. So let's see. I think we have run out of agenda. So I think the floor is open for discussion or.
So real quick, before we do that, can we just go over the existing action items? There's you posting some pictures. There's me, you, and Nick finding out what dates we can use, and then asking people what dates they can show up on to do a build jam session. Were there any other things that came out of this so far?
No, I mean, everybody approved the next round of hardware work, so I was very happy. The silence was golden in that case. So, but as soon as I have the Eagle files in shape, I do intend to put those out for review, and hopefully get any exceptionally stupid mistakes weeded out.
Didn't mean to interrupt. Then yeah, any discussion?
And then, of course, Rob, an action item to set up an install-a-thon so we can all sync up and get our tool chains going and stuff.
Mm-hmm.
Right. Install-a-thon is the word I missed. That's exactly what I'm looking for, is a jam session install-a-thon.
And that's going to be a multiple hour,
right.
It's that's and the idea is that everyone should walk away with the ability to basically program a chip, understand how all of the tools go together, create the tools themselves, go over the all of the go over the ESP tool chain, go over the this is all written in Node.js and VUE and who knows God what else, and the core stuff, which is the cross-platform stuff. There's a bunch of stuff here.
So yeah, so we'll schedule that. We'll schedule that and make that happen. If it turns out it's 2 sessions, that's just more fun.
Yeah, that's.
I think 2 sessions would be called for, and also as a side effect of some of this stuff, you'll be bootstrapping yourself in some areas, most especially ESP32 development with the Expressive IDE offers a fairly rich set of resources that may be of great interest to the folks who up to this point have focused on the Arduino IDE.
We don't do no Arduino. We're real programmers.
Yeah, except that we're running with the stable 4.4.1 toolchain specifically to avoid incompatibility with the Arduino.
Yeah, well, I won't admit to that.
Microchip Studio.
Microchip Studio.
Are you going to support Windows and Linux in the Install-A-Thon?
Sorry, couldn't quite hear you, Paul.
It's my
microphone was.
Oh, there you go.
How's that? Are you going to support Windows and Linux during the Install-A-Thon?
Yeah, to the extent possible.
It's. I don't even have a functioning Windows machine. They're not that different.
Until they are.
Does the Dialog tool run on Windows or on Linux rather?
Yes. The Dialog tool runs on Mac OS, Linux, and Windows. The IDF theoretically runs on Windows, but on Windows you have to use, I'm pretty sure you need to use a shell, either PowerShell or something along those lines. It's very command line oriented. It's not a GUI based tool set.
And the node runs on anything.
But
Right.
those key components.
But the Windows users will be pioneering. We'll be doing some pioneering. I'm trying to pull together all of the Windows pieces and parts to have them on hand, so we don't have to mess with downloading them. But there are mysteries involved with using the IDF with Windows.
Pete, that's what VMs are for on your laptop.
Yeah, I've heard of those. Yeah, I used to work for the company that made VirtualBox.
Son.
You got it.
Well,
Okay,
actually,
so yeah, so we're gonna have an install-a-thon, and we're all gonna learn a ton. It's gonna be great. There's so many pieces to this project. There's the OS on your desktop. There's the OS and the code on the ESP32. There's the digital stuff going down on the actual Dialog chip. It's gonna be great. If we all walk away able to blink a light or read a sensor, I'm gonna be really excited.
That'll be 2 sessions, but yeah, that's the the point is to download all of the specific information to as many people as want to be downloaded to.
Cool.
I do some signal processing stuff as a hobby, so maybe I can bring forth the tool chain that I was using for that, and in my case, setting up basically op-amp filters and things to do signal processing and conditioning.
Yeah,
That'd be really cool.
This could turn into a 3 or a 4-parter too, but they're going to be intensive professional codathons.
Right. So we'll start with the first one and see where we go from there.
Yep. I have nothing more to say.
I was just going to add that there are lots of things to do related to the project where we could fan out some of the work. Dawn has graciously agreed to be the bill of materials person and ride herd on the components making up the hardware and helping with sourcing the parts, and that's going to be a great help. There are other tasks we can. I'll put out I'll take an action item here to put out a little list of roles that would benefit the website. The 2 GitHub repositories could use some work. We really need somebody to come up with project names. I think we pretty well beat on that one yesterday, though. But we just need to find a balance. But I would like to name these things in such a way that we can easily have a hierarchy. So the DC, is it DC Comics or Marvel? No, the Marvel comic character, Minicle, is a oh rats. I've already forgotten what planetary system the guy's from. No, he's a Rigelian. That's it. He's a Rigelian, and so we could conceivably come up with a name for the 10 by 10 centimeter main board that somehow expresses the home planet of Rigel or whatever. I don't know. It's just that that it would be a fun thing for somebody to get involved in, would be to come up with some of these names.
I vote on Farscape type stuff.
Geez, Farscape.
Farscape. Wait a minute.
Farscape.
I remember that.
Yeah, it was an Australian sci-fi.
What about KDC? Each project could have its own KDC cartoon, right?
The same age.
So anyhow, that's all I've got too. So I'm exhausted.
Well, maybe it's time to just call it and say there we are. If anybody's got anything more, let's look into it. Otherwise, maybe it's time to say we did get through it all tonight. Is there anybody who's got questions or interest or wants to raise a different topic or wants to explore signal processing tonight?
Yeah, could you explain the FFT and the twiddle thing on the FFT? We've got about 5 minutes left.
Nah.
Okay.